Roughly 15% of all energy use in the US is residential heating and cooling. And it's this category that's kind of frustrating from the outside because we've had this technology for decades to solve the problem. That technology is heat pumps. The goal is help the 100 million homes that are burning fossil fuels today move to all electric. So we measure ourselves against making a dent in that. And if we can make a big dent in that, as mentioned, that's one of the biggest single chunks of CO2 emissions. So if we can even remotely come close to that goal of taking a chunk of those homes over to all electric systems, I can sleep very well at night knowing we're doing something to sort of massively contribute to that ultimate problem we have today. So that's how we measure success.
Welcome back, Solar Warriors, and thank you for giving us the only non-renewable resource you've got. Of course, that is your time. I promise you are going to get an amazing return on that investment today, as we have an entrepreneur who is going to help demystify, explain a technology that I'm sure you, like me, have been wondering, how in the world does this work? And should I be doing this as a part of my business? The technology at hand, of course, is heat pumps, if you read our subject line, and that's probably why you're clicking through here. You see, heat pumps are hailed as a technology that is going to help massively reduce and decarbonize the carbon intensity of our electric grid, yet many of you still aren't using them or installing them, myself as well, here in North Carolina. We're going to figure out why that is and how one company is aiming to change that. The company's called Jetson. It's run by a guy named Stephen Lake, a Canadian entrepreneur who, after selling his last company to Google, realized that there was more to be done in the climate tech arena, and Jetson is the answer. We're going to find out why Jetson is transforming the HVAC sector with a new heat pump model, I should say, and how it might impact or at least alter the way you think about your business and your own home. If you love these kinds of conversations on the front lines of the clean energy transition, you're in the right place, especially if you're new here. I hope that we earn your subscription on whatever platform you are on. Thank you for tuning in. This conversation, I am sure, will change the way you think about heat pumps and possibly how you integrate them into your own business model. So let's get right to it with Stephen Lake. Stephen, welcome to Suncast. Great to see you again.
Thanks, Nico. Yeah, excited to be here.
So I alluded a little bit to some of the reasons why the audience is going to want to dig into this topic with us. We'll get into a little bit some of the stuff I talked about your previous experience. But in the kickoff here, I'd love for you to just give us a high-level overview of why Jetson exists. What fundamental problem have you set out to solve?
Yeah, we started Jetson to really solve this challenge of adoption of all electric systems in home heating and cooling. And it's this problem that I think many people kind of gloss over or don't know exists. We think about the vehicle in our driveway and, the fuel that it burns, et cetera. But your home heating and cooling is actually one of the biggest sources of CO2 emissions. So roughly 15% of all energy use in the US is residential heating and cooling. So it's this huge chunk, same order of magnitude as passenger transport and things we think a lot more about. So one of the biggest single line items for CO2 emissions. And it's this category that's kind of frustrating from the outside because we've had this technology for decades to solve the problem. That technology is heat pumps. It's been around, I say in the last 5 to 10 years, it's gotten very, very good in terms of performance, cold weather, and so on. But the adoption is still very low in the US and Canada. Roughly 10% of homes today have a heat pump, 75% have a gas furnace in the basement, burning fossil fuels to heat our homes. And sort of from the outside, it's this frustrating problem because it's like technology's there, adoption's not, let's solve it. And as we dug in, what we saw is that the adoption's not there because there's this huge green premium. The price today from a typical contractor to go for a full all-electric heat pump system versus a typical gas furnace and air conditioner is roughly double. Very few homeowners can afford to make that choice, even though the performance may be better and more comfortable, et cetera. And then on top of it's just very high friction. It's this, I have to navigate this complicated web of different models and technical performance specs and which rebates they're eligible for, and trying to find a contractor who's going to be coming to my home and quoting me on this very opaque process. I have to find a separate electrician to do some upgrades. I've got to figure out if that equipment I picked is going to be eligible for the utility, the municipal, the state rebates that I might get. I then have to get permits and apply for all it's just like this whole process that as a homeowner, I'm like, you know what, it's too much. I want my home heated and cooled. I want it to be comfortable. I'd like to save money if I can do it, but it's a big lift to go through that process. And so with Jetson, we'll talk about more how we sort of do that. We looked at that problem and just said there's got to be a way to drive that cost down, make the process much more like buying any other consumer products, make it much easier for homeowners, and as a result, help move the needle significantly on adoption. There's 100 million homes today across the US and Canada that have a gas furnace in the basement or crawl space or attic that should be upgraded to a heat pump. And we want to move the needle on that number.
100 million homes. The fact that 15% of all energy use in the US is tied to heating and cooling is a staggering amount, actually, one of the single largest chunks of carbon emissions that we could tackle as consumers, as individuals. I'm curious, though, why this area of heating and cooling, given that heat pumps are by no means a new technology, why this area of heating and cooling has received less attention compared to other clean energies. We often talk about solar and electric vehicles and batteries, but we don't have a whole lot of conversations here about heat pumps.
Yeah, I think two reasons for that. One is that other technologies are kind of more in the forefront as a consumer. Your vehicle is something you interact with every day. It's this kind of shiny consumer product that you can really package up and sell the benefits of the performance and the aesthetics and how the electric product is better. And as a consumer, it's kind of easy to see that. Your heating system is in the basement or tucked away in a closet of your home, and you rarely interact with that sort of directly. You see the impact and results of it in your comfort all the time, but you don't touch the product in the same way. And so it's when we're out of sight for consumers. You think less about it. Roughly every 15 years, you probably upgrade or replace that system when it breaks down. And you may not really think too much about it other when you're paying your bill every month, kind of between those times. The second one is that the way you do sort of think about it is when you need to repair it, fix it, replace it, and you're typically going to an HVAC contractor. Mm-hmm. Most of those contractors, their experience over the past decades is as largely gas contractors. So they're specialized in installing and working on repairing gas furnaces, gas boilers, water heaters, things like that. So they're not sort of electric and technology contractors, and the technology is very different in a heat pump. It's an all-electric product. It has lots of digital controls. There's lots of sort of engineering into installing it the right way. It's a very different process and product, and the majority, I'd say, of HVAC contractors, even today, are not fully aware of the true ins and outs of how to do a heat pump properly, or even the fact that they can be an option for many homeowners. And so I think those two reasons really contribute to this being kind of an under-invested and something you don't think about as much as a homeowner.
It's definitely something we don't think about very much. And I think almost by nature, the design of the product, it sort of sits in the background. It's a ubiquitous accessory to most homes that, with the exception of places, many parts of California, just about everyone in America has a heating and cooling system, whether or not it's a furnace. I do have a question, though. Is the gas furnace the primary replacement technology for a heat pump? I think this is a misunderstood component about heat pumps as well. It's like, where are they optimally useful?
Yeah, it's a great question. So there's two major categories of heat pumps that are really commonly installed across homes out there. The first is a central ducted heat pump. Mm-hmm. A lot of homeowners are not even familiar that these exist, but a central ducted heat pump is basically a furnace replacement. A unit that replaces a furnace in it. It blows warm or cool air throughout your home and your existing vents, just like your furnace or your air conditioner would today. That's sort of type one. The second one that some people think of when they hear heat pump would be what's called a ductless heat pump. So ductless is like a wall mounted, a mini split. It could be ceiling mounted, but these separate kind of units in each room that are directly connected to your outdoor unit. Those are often installed, very common in the South, or common also in houses that didn't have ducting when they were built. So if you were on electric baseboard heat previously, or you have radiant in-floor heating, you might have a ductless system for cooling, things like that. So that's kind of the split. The majority of single-family homes in America do have ducting, and so are a fit generally and have a gas furnace today. So that's what I'm talking about, and that's primarily what we're focused on right now, is replacing those gas furnaces that sit in the basement, crawl space, attic of a home, and they're connected from that ducting and blowing air throughout the home.
Yeah, it's interesting as well. I think I would argue most people don't think about this, but we hear the word furnace, which we associate with burning, and so the furnace does in fact still provide cooling, or are we just replacing heat?
Yeah, so typically you have two systems in a home with heating and cooling. You have a furnace, and then directly on top of the furnace, you have a second box, which is called your coil, basically. Then you have an air conditioner outside. So a heat pump is just like an air conditioner. It's essentially an air conditioner that can work in two directions. So your air conditioner is working by taking heat energy out of the air that's blowing by it from the furnace, that's pulling it out of the air in your home, moving it outside, and then rejecting it. A heat pump, it's doing that when it's in cooling mode. When it's in heating mode, it's taking heat energy from the outside air, moving that through the refrigerant into a coil inside your air handler unit. The air is blowing over it. That's warming up your home. So that's basically how a heat pump works. It's an air conditioner that's sort of more advanced controls integrated and can go in two directions. It can move heat into the house or move heat out to cool the house.
So I live here in North Carolina, and I have what I believe is a furnace in the basement, and I have this unit that sits outside my window that turns on whenever air conditioning is happening. That unit outside the house, what's that called?
Yeah, that would be an air conditioner. So
that's just the air conditioner.
Basically, essentially a one-way heat pump. You can think about it. That's like
I was going to say, we've been trained in the South to think of those as heat pumps. Like I've been told, the heat pump is sitting out there, blowing cold air in.
Yeah, it's possible you have a heat pump. So in the South, actually, some homes or many homes do have heat pumps in the South, actually higher penetration than the North, surprisingly. Because often if you're going to install an air conditioner, which is basically a one-way heat pump, you can often just make the change and install both at the same time. So there are a couple different configurations. You can have sort of a dual system where you still have a gas furnace, and then you have what may have traditionally been an air conditioner, but is actually installed as a heat pump, basically added on to that. So that's another configuration that exists. That's sort of a halfway step towards it where you still have a furnace and maybe your heat pump is supplementing the furnace in that case.
Very interesting. So I'm not an engineer by training, not particularly sort of a deep tech oriented, but I believe I understand at the base level kind of how technology works. Yet heat pumps do sort of mystify me. They're often described based on how efficient they are as these sort of magical appliances, often getting, I think you mentioned earlier, like 300, 400% efficiency. But they don't, as you just suggested, actually create any heat. They're just moving existing heat. Is there anything that you find as like the most common misconception about heat pumps? And how do you demystify this technology for your team and for investors and for homeowners as you're trying to compel more people to invest in and to use this technology?
Great question. There are so many misconceptions we can dig into. I'll start with a couple of big ones. So the first one, let's just talk about the sort of magic factor. You mentioned the efficiency. And yes, the heat pump is often 300 to 400% efficient. And that sounds like on the surface, even as an engineer, that sounds like that's not possible, right? How can you have something that's more than efficient? I know like a gas furnace can never be more than 100% efficient because it's making heat by just burning the fuel coming in. So if you got all of the heat out of the fuel you burned, you'd be 100%, right? The heat pump's 300%. So how does it work? And the reason it's 300% is, as you said, Nico, it's not creating that heat. It's taking existing heat energy that exists in the air outside the home, and it's using the refrigerant in the heat pump to basically take that heat, increase the temperature, and move it inside the home. So it's essentially using a little bit of power to move a lot more heat from outside to inside. So the heat you're rejecting into the home that's heating your home was not created by the heat pump, it was basically moved there from the outside air. Now, a big misconception would be, well, how is it going to heat my home in the winter if it's moving heat? Like, where's the heat coming from? And when it's minus, 15 degrees Fahrenheit outside. And the reality is, all the way down to absolute zero, there is heat energy in the air. So it may feel cold outside, but because of the refrigerants used in the heat pumps, they're able to pull heat energy out even way below sub-zero temperatures. So that kind of leads to the second big misconception, which is they don't work in the cold. We get that one a lot. This was somewhat true like 10 or 15 years ago. The earliest heat pumps generally had really poor sub-zero temperature performance. So somewhere around freezing or even down to zero, like their performance would drop off a cliff. That's improved dramatically in the last 10 years. So the units we install, they work down to minus 22 Fahrenheit, minus 30 Celsius, and they still have extremely high efficiencies, even in those way sub-zero temperatures. So they've gotten really good. They work in the cold, absolutely. The majority of homes in Norway are heated with heat pumps today. We have hundreds of homes installed here in British Columbia and Colorado, which is even colder. And they actually see, minus 20 temperatures there, heated 100% with heat pumps, no backup heat. The technology is 100% there today. So that's probably number two, is they don't work in the cold. I'd say another misconception we get a lot is that they're noisy.
Yeah.
And this is sort of linked to, if you think of an old air conditioner that was rattling out, in your backyard, they were pretty noisy. Modern heat pump, at least the ones that we install, completely different than that. These are at least 10 times, if not 20 times quieter than that air conditioner. If you just look at that decibel curve, a typical older AC is about 75 decibels. The units we install are somewhere around peak of 55 to 60, but usually operating on 45 decibels. That's
quieter than your dishwasher.
So it's like, literally, we could have this conversation right now, standing right next to the heat pump, and you wouldn't hear anything except for, a light breeze in the background, incredibly quiet, and fully variable speed. So they basically run in very, very low, maybe running at 20% and just slowly ramping up and down to match the needed heating and cooling for the home. So
is it the same as well if you do a central ducted heat pump? Because
exactly.
that's where, like, often some of the noise, the ambient noise, is from the air conditioner turning on and sort of blowing through the duct.
Yeah, so it's similar to your furnace. Like you still have to move the air through the home. The heat pump doesn't change that. I'd say it's often more comfortable inside the home because with the heat pump, so most furnaces are basically 1 or 2 speeds. So when the air turns on, the fan just turns on to speed 1 or speed 2. And so it's basically blasting. The heat pumps are fully variable speed, both the inside and the outside unit. So your indoor unit, which is what's moving the air through your ducts, that fan can from like 20% up to 100%. So basically, most of the time it's running very quietly in the background, just sort of gentle circulating air through your home, which is great for comfort. It's keeping a temperature essentially exactly at whatever your thermostat is set to. Unlike furnace or the AC, which sort of turns on and off. It's just like a 1 speed. So it gets too cold, heat turns on, it gets too hot, it turns off. And the heat pump just ramps up and down to hold the temperature exactly. So you just have kind of this gentle, constant circulation, which is actually great for indoor quality in the home.
Okay, I may be out of depth here, but I'm going to ask what I think is a fairly technical question.
Yeah.
At least on the surface. And I hope that you as an engineer can help disseminate or disintermediate here my lack of knowledge. But my understanding of how an air conditioner works, for example, is that it dehumidifies the air, the home, like it pulls moisture out of the home so that it's more efficient to cool the home. Does a heat pump perform in some different way, or does it also sort of have this dehumidifying function?
It works the exact same way. So a heat pump, when it's cooling, is literally exactly an air conditioner. Generally, it's a very high-end, efficient air conditioner, but it's an air conditioner. It's working the same way. So the way that an air conditioner dehumidifies is that coil inside your ductwork above your furnace gets basically really, really cold. It gets cold enough that moisture from the air is condensing on that. So it's pulling out of the air, turning to water, and it basically drips off the coil and goes down a drain, which pulls that humidity out of the air. And so, to get comfort in your home, you need to reduce that humidity level as you cool the home. And the heat pump works the exact same way. So typically your cooling performance is often better with the heat pump just because it's sort of a more modern, efficient air conditioner, but it's doing the exact same thing. It is important that it's sized correctly. That's something, again, traditional issue that contractors that were less familiar with the technology was when you size a furnace or an AC, usually it's a bit of a back of the napkin. Most contractors don't kind of heat load calculation in the way they should. With the heat, it's important to make sure the contractor kind of knows what they're doing and they've properly evaluated the heating and cooling needs of the home. They've matched it to the heat pump to ensure that it can provide the right level of cooling, dehumidification, and heating required.
I know that one of the barriers that you've concluded around homeowner adoption is that the transition to heat pumps is simply too expensive and too complicated. I've heard you refer to it as the green premium. Can you elaborate on the cost and complexity barriers, specifically this cost premium compared to traditional furnaces, and how we might go about, or how you are going about reducing that?
Yeah. So a typical single family home, the quotes we see from traditional contractors are anywhere from $20,000 to $30,000 for a full system replacement. So that's basically replacing your furnace and AC with a central heat pump system. The same replacement, if I were to put in a new separate AC and a new relatively high efficiency gas furnace, you're probably looking at maybe 12, 14, 15, depending on how high end those units are, how efficient they are, but in the order of sort of half the cost of the heat pump. And on the heat pump side, those quotes are usually broken down and they're roughly 50-50 the materials. So the heat pump itself, all the other materials, the wire, and the labor to install it. And so the reason it's so high today is basically both of those are high. The equipment's expensive. It's lower volume today generally than those gas furnaces. We've just not been selling them as long. There's less homes installed. And then the labor is more expensive. And a lot of that is because those contractors, it's being done less often. So there's folks that replace a gas furnace in half a day, they can do it tomorrow. It's sort of their bread and butter work. That heat pump, it is a little more involved. There's more to do for sure. But also those contractors are not doing it every single day. And so it just takes longer. There's not the efficiency you get from doing something that's really we've optimized the process, we've optimized the tools, the parts, and we do this every single day. And so you've got to move the needle on both of those. There's another layer to it where there's a bunch of work that has to happen in the back end that adds a lot of cost to this that I think homeowners often don't see. And that work in the back end is things like doing your heat load calculations. So you should be doing the heat load calculations to figure out what size heat pump is going to be installed to make sure that home's going to be heated and cooled properly. That takes a fair amount of work to do that manually. There's figuring out the rebate environment. Again, it's quite complex, really overlapping. A certain heat pump might be eligible for some programs, but not others, or certain percentages from some. Like there's a lot of complexity there. So it takes contractors just time and effort and labor to go and figure that out for every deal. There's a lot of paperwork to do all of that. And then generally, permitting is much more onerous in most municipalities for a heat pump than a gas furnace replacement, it's kind of silly, honestly, but that's just where it is today. There's often, depending on the municipality you're in, there's often 3 separate permits you're pulling there. There's often an electrical permit, a heating permit, and a gas permit. In some areas, actually a building permit as well for a heat pump being added on. So there's often quite a bit more paperwork as well that does add to it. So those are, broadly where it stands today.
I want to talk about the go-to-market and operational model. So Jetson operates in an environment where historically big companies like Trane, Carrier, they're well established, well known. They distribute their products to regional sort of hubs or distribution centers, and there are installers who, in many cases, are like trained to do one or more of these units, or they are in some way sort of dedicated to a certain model. But it's a very distributed ecosystem of service providers. Yet my understanding of how Jetson is going to market is a vertically integrated, all the way back to, at least in the very near future, having your own manufactured units, all electric fleets, in-house install teams instead of using local installers. What's the strategic rationale behind building out your own install capabilities and fleet rather than relying on third-party contractors?
Yeah, it all goes back to the discussion we just had on cost. So if we're at $20,000 to $30,000 today, typical contractor, we need to be at cost competitive with that gas furnace and AC. So more like $12,000 to $15,000. So it's on the order of half the cost today, which is where we are. So our typical system is about $15,000 before rebates. After rebates, it can be anywhere from, depends on the state, from $15,000 down to zero, depending on the programs out there, but it extends the rebate. So we're kind of half the cost today. To get there, each of those layers of inefficiency that exist today, we have to aggressively kind of attack and eat away at those. So there's the cost side, which I'll talk more about, is a big reason that we've chosen to be vertically integrated. The second one is quality and consumer experience. It's just getting that process to be something that is easy for homeowners and not complicated, and easy for them to sort of say yes to make that change and remove all the friction to adoption is another big reason we've chosen to vertically integrate. And that friction exists all the way through the process, right? It exists from how you first find out about heat pumps, get educated about them. It exists from the quoting and sales process, the friction of having to have traditional contractors on site and crawling around your home and not having a high level of trust and transparency in the quote. It exists in the kind of pre-install process, any kind of paperwork for rebates or permits required. It exists in the actual install. So many pump installs can take multiple days sometimes. You can be coordinating multiple trades to do electrical work or other parts of it. And then once you have the product, there's a whole nother category we can talk about later on the show, which is like the experience of owning the product could be a lot better. So for all those reasons, we've chosen to vertically integrate there.
Yeah.
I touched on the cost side. So you mentioned the example of, I think, Carrier there. It's a great one. So they're a typical brand you might see there today. If you're going to get that unit from a traditional HVAC contractor, that unit was manufactured by one of a small number of Asian manufacturers that make heat pumps for most of the brands today, was then sold to Carrier, was then sold to a distributor in your hometown, was then sold to the guy in the truck installing it for you, was then sold to you. So there's like 4 layers of margin stacking and markup that end up with that being a $10,000 piece of equipment that could be far cheaper than that on the equipment side. So you have margin stacking, basically cut out that whole middle section. So we work directly. We have our own heat pumps. We work directly with a large manufacturer to build those for us. And we just cut out all that middle markup that happens there. So there's a huge amount of cost savings we can offer on the hardware side. The second one is that we exclusively do heat pumps every single day. So we've built the whole install process, and that includes the tools we use, specific training, software we use in the field to commission and install these systems, a whole warehousing and distribution system, vans, et cetera, that are completely optimized, much more like if you imagine what an iPhone production line looks like, where everything is sort of designed to flow and get that phone built as efficiently as possible, we think about the heat pump install the same way. We've got to, in that one day install, we've got to start there. You've got a gas furnace in the morning. End of the day, you've got a heat pump that's been properly installed at our quality bar. It's working perfectly for your home, and your home's converted to all electric. To deliver on that is a lot of operational optimization and complexity that we've sort of taken on to make that happen. And so that's why we've chosen not to, largely for that cost and efficiency reason, to work today with a network of sort of independent installers. Instead, we've hired incredibly skilled local HVAC technicians, master electricians. We have all of these trades in-house. And we essentially, for any given install, we've got our all-electric van that's going to roll up to your home. It's got the equipment in it, the new heat pump. It's got, color-coded like an aircraft assembly line, all of the tools and the parts needed. It's got a master electrician in the truck, an HVAC tech who's licensed in the truck, and a third technician that's going to basically come and do that process. They're going to commission the system with a full digital process that actually optimizes it for your home. It ensures that, the refrigerant levels were charged properly. The airflow is what we expect it to be. It's performing as we expect it. All that happens in a very kind of methodical, intentional process.
One of the things that caught my attention is I started looking into more about how Jetson is going to market. And I don't know if you guys are actually delivering in this way or if it's just clever use of social media, but the helicopter delivering the Jetson van to new markets, especially the one that says, your crews are en route to Colorado Front Range. You guys have expanded quickly into the U.S. market, starting in Colorado and British Columbia, obviously where you reside, but now into Massachusetts, New York, even Washington State. Let's start with Colorado. What made Colorado such a phenomenal test market for Jetson, in particular, given the challenging climate conditions there?
Yeah, Colorado's been a huge part of our journey from day one. So we're kind of dual headquartered, I'd say, in Colorado and Vancouver. We started both markets at the exact same time. We were fortunate enough to have a great team from this company called Helio Homes that had been installing heat pumps, one of the largest installers of heat pumps in Denver for a number of years before that. So Eric, the founder there, joined us early on and sort of has been our GM for that market and now runs product for us. And so, yeah, Colorado is kind of our dual headquarters with Vancouver. We launched in both those markets at the same time, intentionally because they are different enough markets that we really wanted to prove out that the process we were building was going to be something that could work essentially anywhere across the states. And Colorado is very cold. It's very hot in the summer. It's got the extremes from a climate perspective that make it a more challenging market. And kind of if it can work in Colorado, it can work in a lot of the U.S. Vancouver is a much more temperate coastal market. And just different building sort of stock as well. Houses in Vancouver tend to be quite a bit older, sort of more tight and unique than the more typical Denver kind of subdivision type home that we can install in. So just different characteristics of the installs. And we've learned a ton from the two of those. Yeah. And a big part of our model is being able to learn in different markets, improve the process, make it more efficient, make it better, and then kind of share those learnings continuously as we roll out to new geographies. So we started basically last October with commercial installs. We had done some pilots before that, but kind of full commercial installs in October. We're in Vancouver. We just launched Massachusetts in July, and we'll be launching New York in September. And then essentially every month after that, we'll be in a new state across the US. So we kind of got the model, got a lot of the investments we've made. There's huge investments in software and operations and logistics and warehousing and a whole bunch of things to make all that possible. But we've kind of been investing in that as we've launched new markets, and lots of work to do in each one as we go ahead and launch them. But we kind of have a lot of the back end pieces coming together at this point.
I imagine it'll be a while before I see a Jetson van rolling around my North Carolina neighborhood, but I am eager to know when that would be. I'm wondering around the Helio home. Do you consider that an acquisition, acqui-hire? Like, how did that structure come together so early in the business model?
Yeah, Helio was a great acquisition for us. We did acquire the assets of Helio. They were operating in Colorado for several years before as one of the largest installers of heat pumps there. They had also built a key piece of software as well, an important part of the deal for us. And so based on work out of NREL, they created sort of remote heat load calculation software. And this is a key piece we actually use in our flow today. So it lets us take in a whole bunch of parameters for the home that we can take the footprint, the way it's facing, the year it was built, all sorts of things, the square footage, the number of stories, and produce a very accurate estimate of the heat load by basically modeling the whole building And it's allowed us to do something quite a bit more accurate and faster than the traditional method in the HVAC industry, which is what's called the manual J process. It basically automates that and provides a more accurate heat load. So that was a key part of the deal as well. And then Eric, the founder, is just a phenomenal resource in the space. And so we were excited to bring them on.
That's amazing. I want to talk more about the actual in-house design engineering function. I know that one of the ways that you guys do differentiate is that you do a lot of stuff vertically integrated, but there's already an incredible amount happening just in what you've described of how you're in sort of disrupting the traditional business. And then you get inside the home and you have to start talking about electronics, controls, software. Could you talk about the specific innovations or differentiators that your quite tech savvy team, as I mentioned before, having built and sold technology to a major company like Google, how are you thinking about the existing interface between the device, the hardware, and the user experience?
Yeah, a huge part of our team is focused on software and technology development. A big part of the team came from our former startup, came from Google, et cetera. So we have this kind of core team of engineers that are working on two big categories of problems. The first one is on all of the operational stuff. It's kind of the boring, less sexy behind the scenes, but critical to being able to do this at scale. There are very few contractors that have scaled nationally because there's so much complexity added for every region. We are using software and AI tools to essentially make that possible to scale. So that's kind of bucket one, is like all of the operational stuff. It's doing heat loads, quoting, automating permits, automating rebate submissions. It's like all the software that lets the company run is bucket one. Bucket two is how do we make the heat pump itself and the experience for the homeowner better? The analogy I would make today is if you have driven a modern electric vehicle, so say a Tesla or maybe a Rivian, you probably purchased the car on the website or on the app or something. You just picked it up. Once you have the car, if you have an issue, you just open the app and report it. They remotely pull the telematics and logs from it. They can figure out what's going on. They might send somebody to your driveway to fix it. It's just a completely different experience because the product is kind of digital first and it's fully instrumented. Heat pumps today are nothing like that. They are installed and then they're like a disconnected, dumb device that at its best is connected to like a quote unquote smart thermostat. But the interface between the smart thermostat and the heat pump is just an on-off switch. It's just literally turning the heat pump on and off when it's too hot or too cold. There's no actual monitoring of, is the system performing as it should be? Is the efficiency what you expect? Can you optimize it through software to take advantage of like time of use rates or the fact that you may not be home right now, or can you run in a more efficient mode? There's like all this optimization because the actual heat pump itself is this fully digital device. There's lots you can tweak on it to make it run better. So at Jetson, we've done a couple of things there. One is every home we install something called the Jetson Hub. So it's basically a new control board that controls how the heat pump is performing. We also install a whole home energy monitoring system in your main panel. We install a whole home air quality sensor that goes in the ductwork. And so all of that speaks back to the Jetson app that the homeowner can access. And that gives you both the traditional things you'd expect, like setting your schedules, controlling your heating, your temperatures and all that. But it also gives you insight into instantaneously how much energy is your home. You understand your profile. You can understand how much money you might save if you add someday, which we can talk about. You kind of get a full single pane of glass view into how is my home performing? What's the efficiency of the heat pump right now?
Like every time we talk, it kind of breaks my brain around like what you guys are trying to achieve because it's not just disruptive, it's audacious. I want to have a conversation with your investors because I want to understand how a 34-year-old entrepreneur convinced these investors to go after this entire segment with this business model. And we could get into, if you like, some of the naysayers that used to be like huge fans and they were like, why are you doing this? But I want to stick with what you just said because so anybody in the solar space would understand when you said whole home monitoring. Now you are in effect competing in the Nest Ecobee space, which are trying to sort of from the sort of thermostat arena start to help homeowners with automatically managing comfort. But then you said, I think, electric panel, which is what Span and Lumen and others in the solar industry are also trying to disrupt, which, by the way, is by and large controlled by a big company called Schneider Square D. This is an incumbent space. I have friends who have spent hundreds of millions of dollars and decades trying to disrupt just the electrical panel, okay? We both have friends who've who've spent decades trying to disrupt the home monitoring space. Help me understand the need for proprietary in-house software controls and why the heat pump necessitates this level of full integration.
Yeah. To start, we are not competing with Schneider or Siemens. We're not building panels, to be clear. We install a whole home energy monitor into your main panel. We're not making breakers, we're making panels. So we're
cool.
One last thing on the list to do.
Yeah, good.
But we do provide that whole home energy monitor. We provide also a thermostat as well. But the whole point here is for the homeowner, we want to give you just a seamless way to understand how is your home performing. And then the second piece of that is we want to be able to remotely monitor that system and ensure for you as a homeowner, just give you peace of mind that it's operating. So if 3 years from now something happens, you have an error code, et cetera, we'll know before you know. So all of our systems are remotely monitored by us. So all the hundreds of data points of how it's performing, the current coefficient of performance, the efficiency, the current it's drawing.
This isn't radical. This isn't a radical idea for anybody in the solar space, by the way. This is exactly how solar had to be done.
Yeah. So this all streams back to us, but this is radical for HVAC. There are traditional heat pump. None of them have remote monitoring, or at best they've got like this really sort of basic idea of it. Nothing like this.
The closest I have to controls in my house right now is a demand response switch where Duke can turn my HVAC off because they want to they want to reduce the overall demand on their grid.
Yeah. So demand response is a great segue. That's another piece of the story, happening on a longer term horizon is we are building the infrastructure in the back end. Your heat pump will be your largest electrical load, that and charging your car. And so from a demand response perspective or virtual power plant, et cetera, there's a bunch of models here that are going to sort of intersect here where being able to smartly control and change when that unit is heating or cooling your home is hugely valuable to both the homeowner and to the utilities out there. So that's another whole piece of the story. But just coming back for a second, you talked about a Nest or an Ecobee. I think most homeowners don't actually realize those units, unfortunately, cannot efficiently control a heat pump. And the reason for that is that a modern heat pump is fully variable speed. And so you need what's called a communicating thermostat. That basically means you need a digital thermostat that's going to send the temperature back to the heat pump so it can ramp up and down. Traditional thermostats, which include Nest and Ecobee, et cetera, their interface is just an on-off switch. It's just a relay saying on-off. They may have a speed 1, speed 2, but they have no communication with the heat pump. So when you go and install a current smart thermostat on a heat pump, you actually downgrade it to operating like a single or 2-speed unit instead of fully variable speed, which means your efficiency basically drops off a cliff and you lose a lot of the benefits and comfort you get with the heat pump. So you're kind of stuck as a homeowner. You either have to choose today, I want, a controls with a reasonably good experience, consumer UI and everything, an app experience, or I've got to use this like horrible manufacturer's clunky control from like Mitsubishi or whatever, which is like it was designed in the 1980s by Sony or something. It's just like you've got to use these clunky old sort of like manufacturer's thermostats. So one kind of key reason we created our own thermostat and the app and everything else was to give you the best of both worlds. This coming from a team that works on consumer products, an app that we actually want to use and is kind of an easy, intuitive view of controlling your home while still maintaining the efficiency that you would get with a traditional manufacturer's control. And then allowing us to actually upgrade and increase the value of the product over time. So we can push, just like your Tesla or Rivian, to use the example again, get software updates and makes it better.
Yeah.
Your heat pump from us is getting software updates to make it more efficient, to add features like time of use management or plug into utility APIs, all sorts of stuff there.
So as you mentioned, sort of operational efficiency in the software you're building, I remember an early conversation I had with Peter Rive. I'm not sure if you're familiar with the Rive brothers. They created Solar City, took it public. They're famously cousins of Elon. Elon was on the board, gave them their first 10 million. And I had a conversation with Peter Rive where I was just asking, like, how are you expanding so fast across California when most installers, this is 2009, most installers struggle to meet anything outside of their closest 3 counties. Like expanding is very difficult, as you rightly pointed out. And he said, well, we're doing something quite different. We've built an entire automations operational system that operationalizes things like permits, et cetera. And literally, I could hear you channeling Peter Rive from 15 years ago. And it gives me hope, for one, as they were successful at becoming one of the first, if not the first, nationwide installer of solar here in the United States, that Jetson's got a chance. And it certainly gives me hope because I've done some background on the team that you're building. So I like to turn the attention towards the influences behind Jetson's strategy and long-term vision. In particular, it is the team that you have built. Your team's background includes building North, formerly Thalmic, a leading consumer augmented reality company that was acquired by Google. And I'm curious how this experience of the team in hard tech, consumer product development, scaling complex businesses influenced your approach to home electrification market. And I would love to hear a little bit of your own story about trying to enroll that team to come along with this journey with you into climate tech.
Yeah, a lot of the team, the core team is the team that I've worked with for the past decade or more at North. And so the founding team is myself and two others. We were all founders together at North. When that business was acquired by Google in 2020, we knew basically right away we wanted to do something in climate. It was just clear that all of these problems out there need more people to be applying their skill sets to help make a dent there. And so we had a very clear idea that we wanted to do something. We had our commitments to be at Google as part of that deal for a number of years. So once those were up, we were kind of all focused on getting started on Jetson and something new. Shortly thereafter, many of the first hires were other employees from North as well. So we were fortunate. Our essentially first employee almost on day one was our CFO, Mike Galbraith. He was a very early employee, around number 20 at North. North was 450 people at peak. But he was kind of our adult supervision, if you like, as at the time we were, fresh out of university, 3 young guys starting the business. We hired Mike, who had been an early employee at BlackBerry, one of the big Canadian tech companies of years past, obviously. And he ultimately helped take them public and then was their SVP that ran finance and operations, so ran huge parts of the business there. And came and joined us and was basically like hands-on, doing what would have been a team of 1,000 by himself and never complained about it. And it's just a tremendous operator that helped there. And so Jetson, it's a hugely operational business and just, I think, massive amount of experience there that Mike's brought. We then brought on quite a number of other folks as well. So a lot of our software engineering team and product management team came out of that background as well. And a lot of that is sort of intentional. So outside of the operational stuff, that business was, very different, but very complicated as well. So in North, we built and ran our own advanced manufacturing facility. We had nearly 100 PhDs doing advanced research, developing new optics and new manufacturing technologies for that. We built clean rooms and robots, sorts of stuff to make this kind of product. And so there's a lot of, but not in the same way as a trades business, which we'll talk more about. The other side of that was this consumer product. So we were building a technology, but we were ultimately launching a new category of a consumer product. So we spent a lot of time thinking about how do we make this, what was also a pretty high friction experience initially for consumers, how do we make that a better experience? And so a lot of that DNA of building consumer-facing software and thinking about the product experience has been key things we've tried to carry over in the experience to Jetson, is rather than approaching it from this is how things are done in the HVAC industry, so we should do it that way, trying to bring this is how consumers interact with the best consumer products and brands they interact with today. How do we bring as much of that as we can to this industry that typically hasn't had that sort of consumer lens applied to it? So a lot of intentional hires there. We've also brought on quite a few industry folks as well, because I think being somewhat naive to how the industry operates is both, it's an advantage on some hands because you're not sort of forced to do things the same way, but it also creates blind spots. So we've brought on some very senior HVAC industry veterans that have run, significant sort of national scale contractors organizations to the team as well more recently, that kind of round out the experience. And so, yeah, it's that kind of merger of consumer experience, consumer tech, deep operations, sort of complicated operations. It's running the ERP system and all the stuff we need to ensure we can operate this like multi-company where we're today in 150 jurisdictions and all these things that happen in the back end. And then that industry experience from HVAC, just to make sure we're learning from what people have already kind of figured out in the category as well.
I'll link to an article that was written by one of Canada's greatest tech writers, who wrote a tremendous write-up in the Globe and Mail about Jetson. One of the things that he did very well, that most of us don't have the luxury of being able to accomplish, is he talked to a lot of the folks that have come alongside you. Something that caught my attention, and I'll read from it. It says, the idea to build a vertically integrated heat pump business initially met with some puzzlement. Quote, my immediate reaction was, okay, it's awesome you're doing something in climate, but I really don't like this idea. That was the voice of Mr. Winterfield, one of your early backers and proponents of the work that you did with North. And he explained his fund shies away from consumer-facing businesses that many venture capitalists also don't like hardware and don't like service plays. And he said, quote, "Each one of these is hard to get right. Jetson's doing all three." Take me along the journey of you, a relatively accomplished yet still young entrepreneur going out on your second venture. As we know, many VCs don't back ideas, they back people. So talk me through how you convinced the folks that came alongside to back this idea when it was so clearly out of scope for what they were used to.
To us, we looked at the opportunity. It was just so clear. Like the conviction that we had of, hey, there's these 100 million homes today. They have gas furnaces. It's hugely inefficient today. It's too expensive. There are no scaled or very few scaled national players doing anything like this today.
Yeah.
We had very high conviction. So kind of we were going to do this with or without investors. So we just got started. We didn't raise money on day zero. We just started working on this. And it was, it felt obvious enough once we had done the modeling and kind of had the plan together. It was a very obvious opportunity that needed to be addressed. And so we didn't worry too much about how we would finance it. We just sort of said, let's start doing it. Is to us so obvious that we'll find a way to finance it at the right time.
Yeah.
And then, like a few months in, we started to have some conversations. We weren't planning to raise money yet, but we had more and more nods saying, I don't know anything about heat pumps. It sounds kind of crazy. These are often investors that had backed us previously.
Yeah.
But as we explained the story, they really understood the opportunity. And we had quite a few folks just sort of say, essentially, I'm not raising money now, but we want to be part of this. It's exciting. We see the opportunity. And so, we were fortunate that initial financing came together over, a few days or something. And folks like Mike and others, ultimately took, I think in some ways, a flyer on the team for sure. Like we had, this second time around as an entrepreneur was far easier to raise capital than the first time around. We had built something significant before. We had a successful exit with it. So certainly the team had a lot more credibility. But also I think on top of that, just we have had that 10 years before of operating a business and kind of understanding the things that were important and not important and getting things done. We're able to just make progress, I think, very quickly against that this time around and waste far less time than we did the first time on things that were not important.
I'm definitely going to drill down on that. For those unfamiliar, you raised somewhere around 200 million for North, the company that was sold to Google. What did you learn in the process, then in your 20s, raising money that you brought into this experience, or even as an entrepreneur? Like, can you kind of contrast those two? Like, you raised a ton of money in your 20s, which is not only as a Canadian entrepreneur, which you not in the heart of Silicon Valley, but Waterloo, which is basically the Canadian equivalent. Like, that's nevertheless like an incredible lift. Can you talk about that first time versus this time?
I think two things that were in common for both. So one was with the first business, which was initially called Thalmic Labs, later North. We had very strong conviction in a vision. So it was kind of a category. We had a unique perspective and insight on the industry and the category that was not commonly shared. We spent a lot of time sort of stress testing that, thinking about it, and ultimately had strong conviction that this was a future that we could see existing. And so I think that was hugely beneficial because it just gave us this clarity as we were raising money. We could really tell the story with conviction and paint a picture of kind of where the world could be, and I think show progress against it in all cases. But then the second piece I'd say is that this is like, I think any entrepreneur that's raised money knows this, you just have to have a thick skin. Like everybody's going to say no. The vast majority of people are going to say no to you. So we had in every case, certainly in the first time around, way more no's than yeses, probably 10 or 20 times or 30 times more no's than yeses. But ultimately we just had that conviction in what we were doing, that we were confident that somebody would see what we were seeing in the category, and they believe in it. And so that was a big piece of it. I think we were, strategic about how we told the story and, the way and the investors that we went in and sort of got in front of, certainly. But I'd say the biggest piece was just we had clarity and conviction and an exciting story. And at the same time, we were very scrappy about finding ways to make significant progress against that, even without, before we had all of the capital needed to do that. And we've kind of done the same thing here. We didn't design the business structure in a way that needed $100 million on day one to start this. We designed something that we could start with very modest amounts of funding and get going on, and then certainly continue to invest in as we showed proof points over time.
One of the things that you did really successfully, as with many consumer tech companies over that period from, say, 2009, 2019, is you got something like 50,000 pre-orders, right? So you have this built experience of how to create a consumer desire for a product. Is that something, how does that factor into how you're thinking about bringing Jetson to market? Like, could we conceivably have pre-orders for heat pumps, of all things?
Yeah, so the first product we built was called Mayo, and yeah, that's exactly how we launched it. So this was a product where, we had some small amount of funding. We kind of raised as a seed financing, maybe a few $1,000,000 or something, but we needed sort of tens of millions of dollars to bring that product to market. So we were able to get as far as we could prove we could build a technology. We had, hairy prototypes that were
3D printed. I love that.
3D printed, and we were making circuit boards in this was, a university incubator room. And I think at one point we put a out of order sign on a bathroom stall so we could put our tanks of like acid in there to etch circuit boards overnight. And it was like, very, very scrappy. It was kind of however we could make this work with lines of credit and student lines of credit and credit cards, things like that. We kind of got far enough to prove we could make it work. And then we felt like then as, 1 year out of university graduates, we didn't have the network, the credibility to go and raise $30 million or $20 million to go take that product to production like it needed. So we chose the pre-order route. So we went and launched this pre-order campaign. We were very thoughtful about kind of the marketing of it, how we told the story, got people excited. Yeah, we were successful in getting maybe 50,000 pre-orders or something for the product. We timed raising a sort of significant financing round around that pre-order campaign because we knew there'd be a lot of buzz around it in PR. So there was very strategic kind of use that to show consumer demand, create buzz and excitement, then raise the money. Jetson, I'd say, is a little different. So that product needed this S curve of development, right? We needed to put the tens of millions of dollars into getting the product to market, and even more than that with the glasses product we later built. Our heat pump product, we really designed the business in a way that we could start providing value and installing a product on essentially day one. Like we could take an essentially, off the shelf product on day one. We could implement process improvements we wanted to make and the business model changes and start installing it while investing in the background on some of the more expensive pieces we needed to do, like our first party hardware and software and other pieces. And so the businesses have very different, and this is intentional, coming from that experience in my last business where we did raise a lot of capital, but we were also dependent on that. So ultimately we had, a lot of external constraints on timing, on how we ran the business, because we know we needed to sort of focus on that next milestone. We needed the next check because we were in this deep S curve before we were ready for sort of consumer traction of the product. Invest a lot before we saw real business. Jetson's the opposite, where it's essentially a real business on day one. Like we are cash generating real business right now. And so we're way less, we have still raised capital. We will probably raise more capital in the future, but it's much more optional. It's going to let us pull levers to grow faster as needed. It's not like we need that or we die scenario like it was with North.
Okay. I have a couple of quick questions as we start to wrap up here. And I have a deep question that I want to end with that's a little bit more sort of your entrepreneurial learnings over a decade. But the first is, do you still wear smart glasses and or the Mayo armband?
I still have the smart glasses.
You have them, but do you wear them? Do you use them? Yeah, he's going to show it.
Yeah, no, I would love to. But the Mayo armband, we ultimately sold the IP for that product to a company called Control Labs, who was later purchased by Facebook. And that technology continues on at Facebook. The focal smart glasses. So Google decided to basically continue to invest. So that product became their core bet, still is their core bet for augmented reality. They basically pulled the support for the previous North version of the product while they continue to develop the Google version, which they just showed off finally 5 years later at I/O this year, essentially the same product that we had when we came in 5 years ago. So it's been a bit of a slower process, but anyways, it is still theoretically in the works. And so hope to see that someday from Google. But the software support was pulled for our version once we were acquired, and they've kept under wraps kind of the forthcoming future version of that.
That must be so validating though, to be able to, I mean, you were a kid literally when Sergey walked on stage with the original Google Glass, right? Like, which is laughable as technology compared to what you guys have developed now. I want to point out that your wearable technology startup that you and your classmates founded, Thalmic Labs, was Waterloo's most hyped and heavily funded company after BlackBerry, which you mentioned earlier. I have high hopes that Jetson will do as well as North and better than BlackBerry. And as a former BlackBerry user, I was a huge fan, and I really have loved learning more about the. In another conversation, we could talk about just the deep technological focus. I just had a guy named Michael Worry. I don't know if you know Michael from Nuvation. Just a brilliant entrepreneur who's been at it for ages, and he was the first to tell me about like the whole sort of Silicon Valley nature of Waterloo. But you spent a decade there. You're obviously now out in Vancouver, but you've been deep in this startup ecosystem. And one of the things that you said in the article that I mentioned earlier that I want to end with is that the three of you have learned what is noise and what is signal. We talk about that internally here at Suncast, just as a business. How to put signal over noise is something that Elon Musk talks about. It's kind of now touted, I guess, in the entrepreneurial ecosystem. But one of the things that I want to point out is you feel that now with Jetson, you've been much more focused and heads down executing since you hit go. Can you talk about just that level of acuity of going into your second business and the entrepreneurial lessons that you've applied as the CEO to getting this business into a sense of momentum rather than just being in your head thinking about it and like coming up with the business models? Like, could you just talk about what that means for you, the noise and signal?
Ultimately, we wake up every day and I like to think about what's the most important thing that we all should be doing right now to move the business forward. And there's this great quote of basically most important thing is to keep the most important thing the most important thing. And I think that's just like a way that I think about running the business is we have a new challenge today, and it's easy to be distracted by things that may seem important, but when you really prioritize and think about them, they're not the most important thing to actually moving the business forward. So it's absolutely imperfect. We are learning every day. It's like a work in progress, but our the main focus is essentially, hey, how do we move the football further down the field towards where we're going? I think providing clarity in where we're going is just something learned over the years, especially as the team gets bigger and bigger. Like continuing to provide that clarity to the whole team of this is why we're doing it, this is where we're going, this is why we're doing it, and then ultimately holding the team accountable to deliver against that is a key part of our as founders of the business. Our job is just to keep everyone headed in that same direction, and then the last piece is just to measure that. You can't hide from numbers. And, we spend a lot of time trying to make sure we're getting great real-time data through the whole business to understand, are we growing at the rate we need to? Are we delivering the quality we want? Are customers having a great experience? Are we hitting our operational metrics? Like all of these things, we've just invested a lot to make sure we have like sort of instant visibility anytime into how the business is operating, and that we can, make that visible to the whole company and to leaders in the business to sort of hold them accountable to deliver on the goals.
So quickly, I like to get business book recommendations, or at least if you don't have any, like what's on your nightstand. But is there any particular book, reading, author, thinker who has influenced the way you think about business or building?
I do love I love business biographies of like interesting leaders.
Yeah.
So a favorite would definitely be Phil Knight's biography, Shoe Dog.
Oh yeah, Shoe Dog.
Great one. It's just this combination of both. It's just super entertaining read, and just the way the story is told, but also I think the level of kind of constant hustle and resourcefulness that he had in the early days of Nike is just a great reminder of kind of what it takes and how these seemingly impenetrable, amazing huge companies today started off as like a guy in the back of his car, selling shoes at a track meet, and just the level of like hustle and focus it takes to go from there to the end result. So that's one I love, is like a really easy read, but is a great kind of message and reminder of like where these folks start off.
I have 100 more questions I'd love to ask. I'm sure our listeners, some of them are sort of metaphysically sort of lining up in that category as well. How do you like to be found? Where can folks connect with you and reach you if they're so inclined?
Yeah, you can find me on LinkedIn. You can send me an
And
email.
you're responsive in the DMs there?
Yeah, generally try to be. Can be
Good.
slow sometimes, but I'll try and get them when possible for sure.
Cool.
And then you can find me on Twitter as well, but I'm very, very inactive. I'd say far less active on Twitter as SR Lake on there, but I'd say LinkedIn is the easiest spot.
Okay, LinkedIn.
Yeah.
Yeah, I'm less active on Twitter. If people found me there, I might not see any messages they send me. Last question for you then, Stephen, as we wrap. What will have changed as a result of the work that you're doing?
Yeah, the goal is help the 100 million homes that are burning fossil fuels today move to all electric. So we measure ourselves against making a dent in that. And if we can make a big dent in that, as mentioned, that's one of the biggest single chunks of CO2 emissions. So if we can even, remotely come close to that goal of taking a chunk of those homes over to all electric systems, that, I can sleep very well at night knowing we're doing something to sort of massively contribute to that ultimate problem we have today. So that's how we measure success.
Stephen, we will all be paying close attention and eager to see how Jetson helps to not just disrupt, but revolutionize the home electrification industry. Thank you for taking time to come on the Suncast and share your journey with us.
Thank you so much, Nico. It was fun.